Yeah, hello everyone. So this is Dilip Singh. Welcome to Dilip IT Academy channel. So right now I'm going to discuss about the most important topic about Stream API inside Java language. So we know that as part of Java 8 features, one of the most important feature is Stream API, and we discussed already a couple of other features like functional interfaces, lambda expressions, as well as predefined functional interfaces, predicate, supplier, and etc. And we discussed about optional class in our previous sessions. Continuation to that, right now I'm discussing about Stream API also. Yeah, Stream API is the one of the most important topic with respect to interviews as well as with respect to day-to-day real-time application program. Okay, so yes, in my projects also right now we are using Stream API extensively wherever we are having some kind of data operations. I mean, we are performing operations on the collection of values. So that means in general, at one point of time, what will happen whenever we have collection objects, for example, if you take a list, so if you want to perform any operations on the list object, like if I want to filter some information, or if I want to convert from one value to another value from the list of objects, okay, so we have to go with some regular programming, like we are iterating via for loops, and we are taking a manual if conditions if you want to filter, or if you want to write a manual mapping from one value to another value conversion, right? But now those are all functionalities being replaced by the Stream API features. It means we are using Stream API to operate with the collection objects most of the cases. Okay, now let's understand more about the technical details about the Stream API. Okay, yeah, here we can find the agenda of this session. So what I'm going to cover here. So I will explain what exactly the Stream API and the importance of Stream API, and I will show you the number of ways how can we create the stream instances, as well as we will discuss the most important one called as difference between intermediate and terminal operations in the Stream API. And I will explain about the most important called as stream pipeline, as well as we will discuss couple of use cases also. And the one more important class we have called as collectors, and this class being used extensively along with the Stream API. So what is the meaning of collectors and what are the functionalities available as part of the collectors class also we will discuss as part of this session. And in between this session, I will try to cover a couple of interview oriented examples. Okay, and those are all related to collectors and including the Stream API functionalities. Now the first question here it is, what is stream? So generally here stream is a wrapper on data source. That means what is the meaning of data source? Here it is, for example, if you taken a list of objects, so list of objects is a data source. By using that list of objects, you are creating a stream, okay, that I'm calling it as a wrapper on data source. So that means from the list of objects you are creating a stream and you are processing the data via stream, and finally you are making the operations of fetching or getting the results based on your functionalities, okay, with the help of stream objects. So that means in this case what is happening, the data operations are processing on stream object but not on the actual collection object, or but not on the actual source, I can say here. The importance of stream here it is, stream is providing a way to process the collection of objects, okay, in a functional style, allowing developers can perform bulk of operations in sequence of elements. That means we can perform many operations at a time by using Stream API, like filtering the values. Along with filter, we can map the values, we can collect the results. Like that, we can do many operations at a time without disturbing the source object. So that's why stream is a wrapper on the data source. So stream is an interface, okay, provided as part of the java.util.stream package. Yeah, now we have to understand how a stream will be operated. Okay, a stream is not a data structure. Yeah, but it will take data structure as an input to perform operations. Okay, that means stream will never disturb the actual data source object. Stream will not disturb the actual data source object. So that means when we are doing operations on the stream, those are all not going to be impact the data source. So now let's start discussion about the technical details of the stream API. Okay, first we will discuss how can we initialize the stream object. So we have different ways to create the stream instance or the implemented stream instance from the collection of objects or maybe array of values or in from the individual values. How we are creating the stream instance we will try to see now. So first let me create a class now. So I created a class stream initialization. See how can we create the stream in different ways first. For example, first approach is I'm creating from a collection object. From collection object. That means I will take a list here, the list object. So I will take some values as part of the list. So like that, I'm just having a list of object here it is. Okay, so now from this collection object I'm creating this stream object. So how to create the stream object? Here it is. So first you have to take the list object dot, there is a method called as stream method. So by calling stream method on the collection object like either list or set, we can create this stream instance with respect to this list object. So now if I'm calling this stream, the return type of this method is stream object. Okay, so that means yes. Now finally we are created a stream object. So even here also we can define the generic types. So what is the generic type? We have to define string here because the actual original list object is allowing string generic. So that's why we given string here also. So this is how we are going to create a stream object from the collection object. So this stream object is created as a wrapper on top of this list object. So now by using this stream instance, we can perform the remaining operations. We will see now in couple of minutes. So this is one way. Even sometimes we can create collection from the arrays of objects also. That means if in case if you have arrays of values. So here let's do what I'm doing. Here it is. I'm taking string array something like names equal to, I'm taking couple of string values, and from the arrays we have a method called as arrays dot stream method, and I'm passing the values. Okay, so here names, string names, I'm just passing. So what is the return type of this method now? So it is again a stream of string object. So that means we have to define the generic type always with the stream instance of the original values what contains the data source, the data type of values for original source. We have to configure the generic type here. So this is one more approach, and probably we can create by using couple of static methods from the string also. We can see here, for example, here directly from the method from the stream static method called as stream.off. So here I can pass any type of references. So for time being I'm just dealing everything with this string data type, but we can pass here any data type values. That means we can operate or we can initialize the stream objects with any data type values. Okay, so it's not only string, we can define with any other data types also. So I will take a user defined class and I will discuss the remaining all examples with the user defined class with respect to stream initialization and stream operations. Okay, so how I'm creating, see here, for example, again I'm giving string values here. So that means now one more stream object is created. So the data type is string generic type. So I can create this way also. We can create the stream object from the individual values. From the list object, from the array object, from the individual values, I created the stream object. So now similarly, I can use one more method provided by the stream called as, there is a method generate method. So how it is going to work, we will see now. Generate is the method. So if you see here, this is also a predefined method from the stream interface called as generate. So here you need to provide the supplier interface implementation, the supplier functional interface implementation. In our previous sessions, we discussed about the supplier functional interface. Supplier interface is not going to take any input values, but it is going to return a value always. Okay, so for that, what I'm just doing here as a lambda expression notation, I'm returning some value from here. So generally supplier is all about producing different values at different times of execution. So I'm just hard coded with the one now. It is going to generate a stream object with this value. So here even we can have one more method called as limit method, so that it is going to create the size, the number of values what you given. Okay, so now I created one more way stream object. So what is the supplier return value is string value, right? So that's why here the generic type is I'm taking as string. So stream 4. So the fourth way I have created. Okay. Similarly, we do have other methods from the stream API. That method is all completely depends on the builder design pattern. That means stream provided a builder implementation, builder design pattern implementation. So from that also we can create the stream objects. So it's all about builder method. Okay, so how I'm going to create here. So this is also again from the stream dot builder. So it is going to give you just stream builder object, but not actual the stream object. Okay, so if you see here, it's just returning the builder object. So how I'm going to do here, it is stream dot builder, okay, of the data type what you are trying to store the values, so that you have to pass here it is. So this is not a stream object, this is just like a stream builder. So this is following a design pattern called as builder design pattern. So from this builder, I'm creating now a stream object by passing some real values. Stream dot, okay. So see here, I'm just adding the values like in string value dot add. Again, you can add one more value like that. You can add any number of values, and then finally you are making a call called as build method. Okay, so that means finally this build method is going to create a stream instance with all these values, and it is going to return the stream instance. Now see here, stream of string data type. So we created one more way, stream object. So this is how we can create any number of ways stream object, and even we can create a empty stream also with the method called as empty method. So if you see here, stream dot empty, so what it is going to return, returns an empty sequential stream. Okay, so it's going to return always a empty string. Okay, so this is how we can create the stream object from the source of values, or from the source of collection object or array of objects, or from individual values, or by calling the generate method by passing supplier implementation, and as well as we can define a stream instance with the builder design pattern by calling the builder method, and as well as we can create a empty stream for any other data types. So here I just taken as an example, I taken as a string, but we can define any data type values as part of the stream instance. So stream is going to operate on every data type of values. Okay, so this is all about simply how to create or how to initialize the stream instance from the different types, different ways. Okay, now let's see about the stream operations. Okay, how stream operations are categorized and what type of stream operations we have. So we will see in detail right now. So in stream API, the methods what we are executing along with stream instance, we are calling it as stream operations. Stream API categorized the methods into two operations or two types. The first one is called as intermediate operations, and the second one is terminal operations. So there are two types of methods we have inside the Stream API, and one is categorized as intermediate operations, second one is called as terminal operations. So this is very important, like we have to know the difference between intermediate versus terminal operations, and we will see very detailed with respect to examples also. So here again we have one more concept called as stream pipeline. So that means there is a concept again called as stream pipeline. So by involving these two operations or these two types of methods along with the stream instance, we are going to build a stream pipeline. So we will see details about the stream pipeline also. First of all, let's discuss about what is intermediate operations, what is terminal operations inside the stream instance. Okay, so generally when it comes to the intermediate operations, when we call a method belongs to intermediate operations, it will always returns another stream object of the operation results. Okay, so that means when you are calling an intermediate operation method on instance, once that operation is completed on the stream, so it will return again one more stream object with that affected functionality. Okay, so that means whenever we are calling intermediate operations on the stream, you will always get a return again a stream with the applied functionality. So and at the same time we can call many intermediate operations on same stream instance as a chain of methods. So this is called as pipeline on same source, same stream source. Okay, pipeline on the same intermediate operations, pipeline on the same stream source instance. Okay, and one more point here, it is intermediate operations are executed only once when we invoke terminal operation. So that means on pipeline intermediate operations on the same stream object, so when those are all going to be executed, once you are initiating or invoking a terminal operation on the same stream pipeline. Okay, now we have to know about terminal operations. So generally we can call only one terminal method on any stream instance, and when we call terminal method, immediately we will get the result of all pipeline operations on the stream object. So that means what is the overall points we have to understand here, it is we can call any number of intermediate operations or intermediate methods on same stream object, but at the same time we can call only one terminal method on the same stream, and immediately we are going to get the result of all those operations once we are invoking the terminal method. And whenever you are calling the terminal method, then only intermediate operations are executed which are pipelined on the same stream object. Yeah, if you see here now, for example, we have a collection of object, that means a source of objects, and we call the stream method, and then we got the stream object. Once you are calling the stream method, you will get the stream object, and then you are calling chain of intermediate operations. If you see here, chain of intermediate operation. So when you are calling operation 1, it will return again a stream object. Okay, again on that result stream object, you are calling one more intermediate operation. Again it is going to return with that functionality whatever you applied with that result, one more stream object will be returned. So like that, you can call any number of intermediate operations on the source of stream object. Okay, and then whenever you are calling a terminal operation, generally the terminal operation we will define at the end of all operations, intermediate operations. So once you are initiated a terminal operation, nothing but a terminal method as part of Stream API, so immediately you are going to get a result of all these operations, whatever the intermediate operations we done, and okay, whatever the terminal operation, based on the terminal operation, whatever the intermediate operations, all the consolidated, okay, operations result you are going to get as a output. So this overall chain will be called as stream pipeline. So that means what is a stream pipeline? Here it is. When you are making the sequence of operations like intermediate operations on the same stream object, and when we are making one more terminal operation on the same stream, so then we are making the entire sequence as a stream pipeline. We are calling it as a stream pipeline. So here stream pipeline is nothing but the combination of intermediate operations methods on the stream object as well as a terminal operation. So this entire process will be called as, this entire chain will be called as stream pipeline here. So now let's see what are the methods are provided by the Stream API, and out of all those Stream API methods, which are categorized as intermediate and which are categorized as terminal methods, we will have a look here, and then we will start making a programmatical point of view, every example for every method. Okay. So if you see here, I just noted down all the methods, and that too these methods are very helpful and useful in day-to-day programming. For example, with my entire experience of my real-time applications development, so I collected all these methods, what we are using on daily basis in my day-to-day application implementation. Okay, so if you see here, I just categorized what are the methods we have, what are the methods belongs to which section and all. I just categorized it here. So we know that we already used empty method, off method, okay, all these two methods as part of the stream object creation, right? So now if you come here, we have a lot of methods, okay, so don't worry about every method. So we know most of the methods functionality, what it is going to done, and we will see anyway practical examples also. So if you see here, I just categorized a couple of intermediate methods like distinct methods. So that means what distinct method is going to do, what filter method is going to do, what skip is going to do. So that means these are all methods belongs to the intermediate. So whenever an intermediate operation is executed on stream object, it will never ever return a result directly. So intermediate operation will never ever provide, okay, an output or result directly. So to invoke all the intermediate operations, you need always a terminal operation, and that too we can call only one terminal operation. We cannot call more than one terminal operation on the chain of stream activities. On the same stream pipeline, you have to make sure only one terminal operations, but you can make sure many intermediate operations. But these are all operations when it will be invoked. So it is going to be invoked in the when you are invoking the terminal operation. So once you are invoking the terminal operation, then all the operations will be executed one by one in sequential, and at the end the terminal operation will be executed, and finally you will get the result. So this is all about the execution flow of all stream operations with respect to stream pipeline. This is the most important interview question being asked most of the interviews. Okay, like what is the stream pipeline and what are the rules and regulations the stream pipeline is following, and what are the types of operations we have. So we have to explain all these things. When intermediate operations are going to be executed, nothing but intermediate methods are going to be executed, and when terminal operations are going to be executed as part of a stream pipeline, we will get couple of questions. Okay, so now let's come back to the methods. What we have here, it is we have couple of methods, and I told you already we will see an example for each and every method right now. Okay, and so these are all, until this section we have something like all intermediate methods. So we will see what is the meaning of intermediate and all with respect to practical. And we have a couple of methods. See, these are all predefined methods provided by the Stream API. That means as part of the java.util.stream package, we have stream interface, and as part of stream interface, we have all these methods. And if you see here, there are a couple of terminal methods also. Okay, what are the terminal methods we have? So we will see an examples about terminal methods of all these methods in a programmatical point of view right now. So we have to remember at least couple of intermediate operations as well as terminal operations with respect to interview point of view also. But it's not like you need to remember each and every method belongs to intermediate and terminal. It's not that much easy also. So this is all about the intermediate and terminal operation introduction. Now let's start the programming, how we are going to create a stream instance from the collection object, and as well as how we are going to create a stream pipeline and what are the rules and regulations we have to follow when you are creating the stream pipeline with respect to intermediate and terminal operations. So now let's look into the stream methods. So that means how we are performing operations on the stream instance, we are going to see now. So let me introduce one by one methods, and we will see one by one example how or where we are using the stream methods, in what kind of requirements we are using it, we'll see now. Okay, so let me create a class. I have created a stream operations class here, and what I will do here it is, I will take a list of employee objects, and then we will try to see all the examples along with this list of employee objects by converting into stream instance. Okay, so what I'm going to do now, to save some time, I'm just pulling an employee class and I'm preparing a list of employee objects as a array list object, and we will try to understand all the stream methods with respect to this list of objects. So now I created an employee class with all these properties, like we are having ID, name, city, age and gender, as well as we taken department, year of joining into that department, and the respective salary for every employee. Like that, we collected all the properties as part of the employee class. Okay, so now in that another class, I just taken a list of employee objects. I taken around 10 employees data here. What is their age, what is their employee IDs and all. So I just covered as part of this list. And now here we will start understanding about the stream methods, or we can call it as stream operations also. Okay, so how to do that? For example, assume I given a requirement like this: get all employee names as a list. So this is what the requirement I given to you. From this list of employee object, you have to collect only employee names as a list again. So then what we will do in our regular programming, or in our previous, before to Java 8, probably we will iterate all the employee objects like this. And here you will write down a list of string, because name is a string value. So employee names equal to new array list, right? And then what we will do, employee names dot add, and every employee dot get name. Okay, so this is what you will do, and finally you are going to get the employee names. Okay, let me print it. So all employee names, fine. Okay, let me execute now. So see here, you got all the employee names as per the requirement. But now, instead of doing this kind of imperative programming, like we are writing implementation with respect to creating new list, and again we are iterating one by one, and we are doing the imperative programming here, right? So instead of doing this kind of imperative programming, generally we know the purpose of the lambda expressions functional interfaces to improve the declarative programming in the Java language. So that means now if I am using the stream methods with respect to same requirement, okay, how I can do, let's see, here it is. So the same solution, but we are implementing via stream now. Okay. So first and foremost thing is we know that how to create the stream instance. We have to collect or we have to create always stream instance from the collection of objects, right? So collection type. So here I have list is a collection type, so I can create from here. Okay. So by calling a method called as stream method as we discussed earlier. So once you are returning what you are going to get, you are going to get a stream object. For example, I can write down like this stream. So what type of values you contain inside the stream? Employee type. So you are going to contain employee type values here. Okay, so let me import the package also for the stream and then employee stream you got here. Okay, you got all what? Employee stream. So on this stream, now we discussed like we have two types of operation called as intermediate operations as well as terminal operations. So first, generally to perform any functionality, most of the times we will use intermediate operation, and to pick up the results once or to collect that result from that intermediate operations we will use terminal method, and this overall process we are going to call it as a stream pipeline, right? So for example, in this case stream provided a method called as map method. So here I'm just taking stream object, okay, and then I'm calling a method called as map method. So what is the argument for the map method? The functional interface. So you know we know about the functional interface. It will take input as a one value and it will return one more value as a nature of the functional interface, as we discussed in the previous sessions. So that's why we have to know function, predicate, supplier and consumer before understanding the stream API. So we already covered that session in the previous. So here that means as per functional implementation, I'm going to take every employee object. Okay. So here this is representing every employee object from the stream of objects. Okay. I'm collecting one by one employee object, and from that what you are trying to get, employee dot get the name. So that means from every employee object you are collecting employee dot name. So what is this operation type? Map is a intermediate operation. So we know that any intermediate operation will not give us the result, the final result. So to execute, to get the functionality executed of intermediate method, we need always a terminal methods, right? So if you see here, map, okay, if you understand the map, it is what? Intermediate operation. So intermediate operation will never ever gives the results, okay, on stream pipeline. So to conclude the stream pipeline, we need always a terminal method. So out of all these terminal methods, we have to collect a terminal method with respect to the requirement point of view. Yeah, for example, if you see here, I'm calling a method called as toList method. So this is a terminal method. So if you see here, this is a terminal operation. So what it is going to do? A list containing the stream elements, and it is being added from the Java 16 onwards. So that means this method, this terminal method we don't have earlier before the Java 16, or from Java 8 to until Java 16 we don't have this method. So at that time we used to use a concept called as collect as, and collecting as a list, like that we are having a concept, and we used to use that functionality before the Java 16. If it is Java 16 or more greater than the Java 16, then we can use directly toList method, which is a terminal operation. So I will discuss in case if it is less than Java 16, okay, how we are going to collect the values from the intermediate operation called as map, okay, by using collector class. We will see in the upcoming operations. Okay, so now let me call the toList method here. So I'm just calling the toList method now. So see the return type of, if you have observed here, so this overall I'm calling it as now stream pipeline. What it is? Stream pipeline, as we discussed in earlier class. Okay, so here in this case, this is what? Source. This is what? Intermediate operation. This is what? Terminal operation. So this is source. This is intermediate operation. So intermediate, it's not like final one. And it is all about terminal. It's all about terminal operation. And by overall this, we will call it as what? A stream pipeline. We are calling it as a stream pipeline. So we built a stream pipeline and we are finally, so and we discussed one more point also, like whenever we are calling terminal method, we are concluding terminal method, and we know that we have to call always only one terminal method, but we can call any number of intermediate methods. We will see those things in upcoming examples. Okay, so now once we are calling the terminal method, then immediately intermediate operations will started executing first. So then it will be executed. So from here, from every employee object, you are collecting the names. So then internally it will collect 1, 2, 3 like that, all employee names, and finally as per the terminal operation, it is going to make everything as a list of values based on the return value from the map. So what is the data type of return value from the map functionality? String data type. So here you are going to get list of values with data type string as a result. Okay, so let's see now here. So what is the return type of this method? If you see here, list of string here. Why string? Because this return value is data type is string. Here it is. Okay, so let me collect this value now. List of string. Okay, all employee names. See how clear it is, or how simply we return the functionality of getting all employee names when comparing with the declarative programming. Like we are going with the regular for loops and writing like regular, okay, functionalities. We are overriding those things with the stream API. No. Okay, let me just print all the employee names one more time. So whether we are receiving properly all the employee names or not. So run as Java application. If you see here, even we got same result with respect to stream operation also. Okay, so this is how the stream API is helping us nowadays writing very significant code, okay, as well as writing very comprehensive code instead of going with the regular approach like iterating the for loops and making any conditional statements inside the for loops. When you want to extract data or when you want to collect any when you want to collect a data based on any conditions, instead of going with this approach, we are going with this stream API approach. Okay, so we will see a lot of other examples also how stream API is helping us with other requirements also. Okay, so this is all. Okay, what we understood now in the overall process here it is, we understood now about the map method. So map is a method, okay, derived as part of the stream API, and this map method is going to take as an argument function interface implementation. That means function is a functional interface. It will take one type of input value, and after processing that input value, or you are doing any mapping or manipulation on with that value, and you have to return always one more value. So that is what the functional interface returns. And again, if you observe here, we already discussed in earlier case also. So an intermediate function or an intermediate operation will always returns again one more stream object, but not actual result. So the same thing is being applied here also, if you observe now. So when we are calling the map method, the return type is completely stream object, but when you are calling the toList method belongs to the terminal operation, you are getting the overall result, terminated result, right? So let's see the other methods also, like what we have going to use on daily basis in our day-to-day application programming. Okay, so you understood now what is the purpose of really the stream API when comparing with the old approach of coding and with respect to stream API coding. Okay, so let's see here. Now I will take one more method called as filter method as part of the stream API. Okay, so here now what I am doing here, it is I already have a employee stream object, right? I already have a employee stream object. Okay, I am using that employee stream object and I am calling filter method. What it is? filter method. And as part of the filter method, what is the argument, guys, here? Predicate. So predicate functionality we know, right? We discussed already. Predicate will take a value internally and it will always gives us a boolean return type value, boolean type value as a return type, because predicate is all about conditions. So we are going to apply some conditional statement as part of the predicate implementation, and based on that we are going to get always either true or false results in predicate. So here, for example, my requirement here it is, let's see here, I have to get all the employees whose age is greater than 25. So what I'm going to get, all employee names when whose age is greater than 25 I have to get here. So see here what I'm doing, I taken the same initially created stream object and I'm reusing that stream object and I'm calling the filter method. Now I'm providing implementation of the predicate functional interface. So what stream contains, what values always it contains? It contains internally employee objects. So see, understand how to write down the methods or how to implement the methods as part of the stream API. You have to be understand very clearly. So it's a very simple. Stream object contains what type of content? Employee content. That means employee type objects. So whenever you are taking, so again you are going to get what? An employee object. So predicate will take single input parameter, okay, and it is all about employee object. And from that employee object, what you are trying to do? You are trying to compare age with respect to what? 25. So here this will become the predicate implementation, a conditional statement. It has to represent always true or false value as part of the predicate implementation. Okay, as a lambda expression implementation we taken for the predicate argument of filter method. So yes, and once whose age is greater than 25, what you have to do? You have to collect their names. You have to collect their names. So with this operation, what you are going to do? It's an intermediate operation. If you see here again, filter method is returning again a stream object. That means it's an intermediate operation. It's not a final operation. It's not a terminal operation. And from this, okay, now in this case, what is going to happen here? It is, okay, it is going to filter all the employee objects whose age is greater than 25. So that means as a result, what you will get again? Stream of employee objects only. But you will, the values contains internally stream is all about the employee objects whose age is greater than 25. So from that stream, again what you are going to do? I am going to map, okay, the filtered employee names. I am going to mapping here, okay, employee dot get name. So what I did here, I taken two intermediate methods. The first intermediate method is doing what, guys? It is just filtering whose age is greater than 25 out of 10 employees whose age is greater than 25. And then from those filtered values, I'm picking or I'm getting those employee names. And finally, I'm converting it to the to list with respect to terminal operation. So then finally, you're going to get the list of employee names whose age is greater than 25. So here what it is, it's again an intermediate operation. Okay, and similarly, so this is also what? Second one also an intermediate operation, right? So yes, and the third one is terminal operation. The third one is terminal operation. So that means terminating the stream pipeline so that we are getting finally the result here. Okay, so let me collect the values as a return whatever you are getting. So you are getting list of string whose age greater than is 25, right? So employee names, okay, I'm just taking here it as, okay, so I'm just differentiating employee names too. Okay, so let me print it now, sys out of employee. So I'm just printing now the result of employee names too, and I'm just printing here it is. Okay, so let me execute the program now. So see here, there is a surprise. Okay, what is that surprise? Here it is. Just understand the exception. Okay, and then I'll explain you what is this exception also. Okay, so here if you observe the meaning of this exception, until this it is processed successfully and you can see the names of the employees. Okay, this is printed, this is printed. So that means until this you don't have any problem until line number 28, but you got problem at line number 33. And what is the problem or what is the exception it is saying? Just understand, illegal state exception, stream has already been operated, okay, upon or closed. So what is the point? Here it is, and you are getting at what line? Line number 33, you are getting illegal state exception, and it is saying like stream has already been operated upon or closed. So simply what it was saying here it is, so we should not use a stream object more than once. So that means I created from the list of object, what we did, we created a stream object, right? We created a stream object like employee stream object, and we used the same stream object for the mapping method to collect the list of names. That means we already built a pipeline for this map operation here, right? Here the stream object we are already used once to perform some operation, not only map, any operation. So that means we already used a stream object once to, and we built one pipeline and we executed a couple of operations on the stream object, and we are trying to reuse it on the second time. Then you got an exception. So that means now what stream API is saying here it is, a stream object can be used only once. Okay, you can process only once and you cannot process more than once. So only once you have to process, only once you have to process, but you cannot process more than one. More than one, we should not process. So that means the same stream reference, you cannot use second time onwards. You cannot use second time onwards. It is not allowed. It's not allowing. So that's why the exception, you are getting like illegal state exception, and it is saying like stream is already closed. So yes, so that means what is the overall concept here it is, guys? From the, once we created stream object, we can perform only one time stream pipeline operations on the stream instance. We should not use same stream object second time. Then what you have to do? If it is not allowing to use the stream object second time to perform any other operations, what you have to do is you have to create one more time, one more stream instance from the actual source object. So you have to create second time, I mean freshly you have to create a stream object. So this will be asked in interviews also. Can I reuse the stream object multiple times to perform different operations? No, we have to use stream object only once to perform operations, and if you want to perform second time any other operations with respect to stream, same stream instance, you will get illegal argument exception. So to avoid that, what you have to do is whenever you are making any new stream operations, every time you have to create a new stream object. Okay, so that means what is the solution here it is. Now if you're going here, what is the solution? Let's don't use the same stream object and let's create one more time stream object from the original source. What is the original source? List of employee objects. From this, what I am doing here it is, so it's a employees dot stream. Okay, and I'm creating stream object. Now what is happened here? You created one more time stream object and you are performing respective operations, and we are performing respective intermediate operations and as well as terminal operations. Now let me execute. So what we did here, guys, we created one more time stream object to perform other operations. It's not like we are not using the existing stream instance. Okay, let me execute now. If you see here, you got the names of almost 7 people. Okay, yes, for total 7 names you got. That means their age is greater than 25. Those people names you got. Now assume, okay, I think now you understood very well about the stream operations, how to reuse the stream instance, whether we can reuse it or not, or what are the rules we have to follow when you are performing the stream operations. So here you have to remember a couple of things. Here it is. What it is, you cannot reuse stream instance second time. Okay, you cannot reuse stream instance second time. Point number one. Point number two, a terminal operation will gives always the result, okay, the result, but intermediate operations will never ever provide you the results. Intermediate operations are going to perform only mapping or any functionality implementation, or we can do any functionality implementation as part of the intermediate methods, but to collect the results out of all the intermediate operations, you have to call always a terminal method. So that means a stream pipeline always required and terminal method even though there is no intermediate method. Okay, so once terminal method is there, then automatically first this one will be executed. That means here from this what happened, guys, when first intermediate operation is happened, 7 objects is received internally, 7 objects are filtered when first intermediate operation is executed. So then out of those 7 objects, a stream object is created. Okay, as a result, what, with one more stream object is created with this 7 object, and with this map method, what you did, out of these 7 objects you are picking one by one employee names, and total you got 7 employee names, 7 employees names whose age is greater than 25. So this is what about the stream operations. This is how we are going to build a stream pipeline, and this is what we have to follow with respect to rules and regulations for the reuse of stream instance. So now what I'm going to do, I'm going to introduce one by one other methods what we are using on daily basis in every real-time application on top of stream object. Now I have a requirement. I would like to print all city names of employees. Okay, so I would like to print all the cities belongs to all the employees. Okay, so what I'm going to do, see here it is. So we know that we cannot reuse the stream instance when we are doing newly operations, right? So I have employees object, list object, and from that I'm creating the stream object. So what we are created here, stream object. So by using stream object, what you have to do, first I'm going to map, what I'm going to map, from every employee object I am getting employee dot get city. So that means here I am using an intermediate operation, okay, for what? For mapping city values from every employee object. Okay, so what you are going to get here, you are going to get a stream object with the values of city names, and from that what we are on, okay, unique values. For that we have a method called as distinct method given by the stream API. So what is the method we are discussing now? Distinct method to retrieve distinct values from the stream of object. Okay, so from this what is my requirement? I have to print, right? So we have a method called as for each method. Okay, we can use that for each method as part of stream API. That means if you see here, distinct also an intermediate operation. How can I say this is an intermediate operation? So if you see, the return type is what? Again a stream instance. So every intermediate operation will always returns a stream instance, but terminal operation will only perform the real execution. So here what I'm using a method called as for each method. So here we have a consumer implementation, consumer functional interface implementation. So we know that consumer, what it will do, it will take a input value, but it will not return anything. So that means what I'm going to do here, it is I'm going to take a concept of printing all the values, system dot out, and I'm printing every value. So I'm just using method references concept here, so that every value. So in this case, what is happening? A stream object, an intermediate operation. With this, you got city values, and then from out of city, or you are collecting only unique city names, and then you are passing one by one city name to the system.out.println with the method of for each. So see here, what is the return type of for each? Void. So that's why, and this is calling it as a terminal operation. So what is this? This is a terminal operation. So we have to call only one terminal operation, but we can call n number of intermediate operations on the stream object. Here first this operation is done, and next this will be done. So all the aggregated results are going to be concluded, and finally you are printing the values. So see here, so we covered here two methods, guys. One is one more method called as for each method. So it's a terminal method. So what is the nature of this? So it will process each and every value, okay, based on the consumer implementation. So it will take a input value and it will process the value based on our logic, but it will not return any value when we are using consumer implementation. But for each method is taking argument of consumer implementation. So please refer consumer functional interface, then we can easily understand what's happening as part of this for each method also. Okay, fine. So let me execute now. If you see here, Pune and Hyderabad, two values we received. So let's observe the employees belongs to what are the cities other than Hyderabad and Pune. So if you see here, every employee may belongs to either Pune or Hyderabad, and we don't have any other city names. But in case if you have any other city names, we might have see the result here. So what's happening here? The distinct method is taking distinct values, and for each is processing every value from this result of stream. Fine. Now let's move to the another requirement or another method to understand the stream functionalities. Okay. So see here, now my requirement here is get count of employees whose salary is greater than 20,000. So what is the requirement? I would like to get all employees count whose salary is greater than 20,000. Okay. So what I have to do? First let's create the stream object dot stream. Yes, you created a stream object. Then from that, let's observe what are the methods we have related to the count, or what we have to understand first. Let's see here. So what is our requirement, guys? Here it is very clearly the number of employees count we have to get whose salary is greater than 20,000. So how to do that? First thing is, this stream object contains which objects? Internally, employee objects. So from that, what we can do now? First, let's get the whose salary is greater than 20,000. Like, so what I can do? I can use the filter method like what we discussed in earlier case. So I can apply a predicate here. That means a condition. So what it is? From every employee object point of view, whose employee salary is greater than 20,000, whose salary is greater than 20,000 you want. So what filter method will do here? It is filtering all the employees whose salary is greater than 20,000. So what is the result? Again, you are going to get here it is. It's an intermediate operation. You are going to get stream of employee objects whose salary is greater than 20,000. But we want count, right? So what is the method we have? Let's see here. We have a direct method called as count on the stream object. So what it is this? This is also a terminal operation. So this will return directly count value. So that means how many values available inside the stream, that count you are going to get. Okay. So this is how you can use the count method when you want to count the number of values available inside the stream instance. So here it is a terminal operation. This is a intermediate operation, and this overall I can call it as stream pipeline. So let's see whether it is collecting the count or not, whose salary is greater than 20,000. So what I'm doing here, so I'm just taking count of employees with data type long. So let's print it now, count of employees, run it. So you got total 6 employees available whose salary is greater than 20,000. Okay. So yes, now what is the method we are done now? Count method. So it's a terminal method. So we are going to get count of objects or values available inside the stream object. So this is all about the count method, right? Now let's move to the few other requirement, and we will try to see any other important stream API methods available or not. Okay. For example, now my requirement here it is get first 3 employee objects. So that means out of 10 employee objects, I want to get first 3 employee objects as a list. That is what my requirement. So what I can do here, see here it is. First you have employee object and what you are going to do, stream, right? Stream object you created. Yes. Once you created the stream object, what you can do here it is, we have a method called as limit method. So what limit method is going to do? It is going to limit based on the value what you are passing for the argument. So it is going to limit with the set of values initially available in the stream object level in an order. So let me do one thing. So I given here 3. Okay. And then what I'm doing, I'm just making to list. So guess now what is going to return to list? A list of object. Okay. A list of which objects? Employee type objects. So you are getting first 3 employees. You are getting first 3 employees. Fine. So let me see whether it is true or not. So it's out of first 3 employees information. So here what is the method we discussed, guys? Limit. So it is just limiting the number of objects available inside the stream object, and it is giving us those limited set of values to the next operation. So out of total 10 employees, it is limiting first 3 employees, and those 3 employees on top of those 3 employee objects, you are doing the other operations. So here you can do any other intermediate operations, and you can do any terminal operations with these 3 employee objects. So it's up to, based on our requirement, we can do any other functionality, because it's an intermediate operation. It is returning again a stream instance only, so that we can call if we want any other intermediate operations also. So let me execute now whether it is working or not. So see here what you got, the list employee 6, employee 7, that means ID 7, and you got employee 3, 6, 7, 3 employee information you got. So go and verify the list of objects. See what you have, first employee 6, employee 7 and employee 3. So you got these 3 employee objects because of the limit method. It is limiting the values from the stream object, and it is making a subset. I can say like with this number, it will make a subset of objects from the overall stream objects, and it will return again one more new stream object with that subset of values. So we discussed about the limit method now. Fine. Now let's move to the one more operation or one more method with respect to the requirement point of view. For example, now I want to skip first 3 employees and I want to collect other employees data. So what I have to do? So in previous operation, you are collecting first 3, but in the current operation, I want to skip first 3 employee objects. That means the remaining employee objects I have to get instead of 6, 7, 3. So what I have to do now? So same kind of operation. First thing is, so okay, you have employees object, and from that you are creating stream object. Okay, this is common. Fine. Then in earlier case, you used a method called as limit method. Now here Stream API provided a method called as skip method. So what it is doing, the number what you are passing as part of the argument. So I given 3 here, right? So it is going to exclude 3 employee objects from the list of objects inside string and processes other objects and creates new stream object. So that means first 3 will be skipped, and the remaining, with remaining employee objects, one more stream object will be created with the skip method. So that means see here, now to list I'm just collecting. So see what is going to happen. 10 employee objects available in the stream, and it is skipping first 3 and collecting the remaining values. Just opposite to the limit method. So whether it is true or not, let's see here now. So here I'm just taking a variable name except first 3 employees. Okay, that is what, right? So let me print it now. So run as Java application. So see here now, you got an employee list, okay, with all the employees except 6, 7, comma 3, and then it starts from the 8, and you can see all the other 7 employees information other than 6, comma 7, comma 3. So if you see here, now the count started from the employee ID 8, 9, 10, and you got all these values. Just opposite to the limit method, skip. So you are just skipping. So is it clear now? So what we discussed now? Skip method. So see, now you have to understand the importance of Stream API, how significantly we are writing the code with respect to any operations without writing the regular format of iterating the list of objects, and then we are processing conditional statements. So this is just making a declarative programming. Okay, so now let's take one more method from the Stream API called as any match method. So that means when we are going to use this method, what is the purpose of this method, we will try to understand. For example, assume I have to verify any employee under age 18 years or not. Okay, so that is what my requirement. So what I can do here with respect to stream operations, employees dot stream, yes, I'm creating a stream object, and from that stream object, so you can call the terminal method called as any match method. So what it is taking internally an argument predicate. Predicate is nothing but a conditional implementation, and it will return always a boolean value as part of the predicate implementation. So it's a terminal operation. So that means you cannot call one more method on top of any match operation because it is returning finally a boolean value. So here what we have to verify from the stream, so stream will contain employee objects. So that means from each and every employee point of view, we are checking employee dot get age less than 18 years. If anyone else is there, then this method will return true. In case no employee available less than 18, then it will return false. Okay, so see here, I'm just taking result boolean is under age. Okay, so let me print it now. This sort of is under age. Okay, so see here, let me execute the program. So what you got? False. That means every employee is greater than 18 years of age. So if you observe here, there is no employee with 18. For example, let me make it as 28 years, just as a test case point of view. So I given 28. Now let me execute. You got true. So that means, yes, there are employees whose age is less than 28. Yes, we are already having, if you see here, we have a couple of employees who is having less than the things. So that means the any match method finally producing a boolean result by applying the predicate implementation with respect to stream values. That is all about the any match method, and it is very simple and straightforward method. So now let's take one more method called as all match method. So what is the meaning of all match method? We will try to understand now. So it just like similar to any match, it is somewhat opposite to the any match method also. So for example, let's take a requirement. Okay, how can we satisfy with this all match method? We will try to understand. For example, I want to check every employee joined after 2010 or not. So that means every employee here, I want to check every employee joined after 2010 or not. So that means out of 10 employees, if anyone else is joined before 2010, so then I will get false. In case if every employee is joined after 2010, then I will get true. Okay, that is what the meaning of all match. If any one of the element is going beyond the conditional of all match method, then it will return the false. Every element should satisfy, then only you will get the true. Okay, so let's see how to implement it. Yes, let me create employees from the list. I'm creating the stream object, and from the stream, what is the method, guys? All match method. So here any match means if one value is matching, then simply it is terminating the result and it is providing true value. Here everything should match, then only true. If any one of the value is not matching based on the conditional statement or predicate implementation, so then it will return the false. Okay, let me take So here stream will contain employee objects internally, and from employee object what we are taking, get, joining, year of joining, right? So year of joining should be greater than 2010, right? So this is the statement we are talking here it is. And what is the result? Again here it is boolean result. Okay, so let me take a return value here, boolean result. Simply I am taking. So what is the result? We will try to verify here. Sys out of. Okay, so I'm just passing the result. So please focus on the last line of the output, what we are going to get now. So what you get? False we got. So that means there might be an employee who joined before, okay, 2010 also. So if you see here, anyone else available? 2016? No, 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 no. 2009, because of this employee we got the false. Okay, we got the false. For example, let's do what I will do here. It is I will make 2011. Okay, so that I'm evaluating one more time same method, and I'm trying to see the result now. So if you see here again you got the false. So what is the reason? Just verify here you have 2010. So that means here we taken only after 2010. So but in this case only after 2010. So let me make this one also 2011 now. Okay, so let me execute it, run as Java application. What you got? True. So that means now all the employees joining here is making true based on this implementation. For every employee object, the predicate implementation or the predicate execution became true. So that's why overall results you got it as true. Okay. So now let's move to the next method. What we have to take care, here it is. So now let's take one more method what we will use on daily basis. Here it is. Similar to all match, we have one more method called as none match. It is completely opposite to the all match method. So that means as part of the none match method, the predicate what we are going to implement here it is. So it should not, okay, become true for every employee object. So that means everything should become false. Then you will get true result in this case. So it's simply opposite to the all match. When all are matching this implementation, then only you are getting result as true. If any one of them is mismatching, then you are getting false. But in this case, any one is matching, then what you will get? Then you will get false. If anything, no one is matching, then only you will get the true here with respect to none match method. So let's take a requirement here also. Let me give you a requirement. So what we can implement here it is. For example, I would like to check every employee salary is under 10,000 or not. So what I'm going to do here it is C stream dot none match. So what this method is saying, returns whether no elements of the stream matching the provided predicate. So if nothing is matching, then you will get okay true. If any one of them is matching, at least one element is matching, okay, then you will get false result. Here it is. Okay, let me take none match, and what is the object it contains? Internally employee objects, and employee dot, we are applying predicate on the which column, I mean which property. It's all about the salary property. And what is that? We have to verify every employee under 10,000 or not. So let's see the result. Here it is now. Okay, I'm just taking result variable and let me print the result now. So see here what will happen. Every employee salary less than 10,000. If you taken here, we have every employee salary is greater than 10,000. Okay, so see here what is our expected result now. So what you got guys? True. So that means yes, every employee salary is greater than 10,000. So that means false for the first employee, second employee false, third employee false, like that. For every 10 employees, it became false, 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 false. Okay. So false, 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 false. So everything is false. So overall result is true. For example, let me make one value as 9,500. So just to make sure the functionality is breaking or not, I mean it is returning false or not. See now, out of 10 employees, 9 are not matching, but one employee salary is matching with this condition. So that's why if anyone is matching, any value is matching, then you are going to get the result false. right? So it is working as expected. This is how we have to remember. There are three methods. One is any match, all match, none match. So different scenarios, we can use these methods with respect to stream operations. So now let's move to the one more method as part of the stream API. So we have a method called as find any method. So what is the purpose of this find any method? I will try to explain. For example, when you are taking a stream object on top of list of values or a collection of values, I want to take one value from this stream that might be any value. Okay, simply I want to get a value from the stream of elements. So then I have to use find any method. When stream is having one or more than one values, and out of all those values, simply I have to get one value from out of all values. Okay, out of all values from the stream, then I can use the find any method. So in this case, find any will return, okay, different cases, different value on top of the stream object we can expect. Okay, different times, different values, because any value, it's not like there is nothing, you are going to get always a specific value from the stream of values. Okay, so see here, what I'm going to do here, it is employees. Yes, I have employees list, and from that I'm creating stream and I'm calling a method called as find any method. It is also a terminal method. So generally find any method is returning what? Optional of employee object. So why? This stream belongs to what? Employee object stream. We are okay, this is employee object stream. So that's why here you are going to get employee stream. For example, if you are getting extracting employee names, and if you are writing find any, then that stream will become string values of the stream, and then find any will return optional type object with string. But in this case, it contains employee object, so that's why find any is returning what? Optional of employee type, optional of employee types. So we know that about the optional class. In previous, I already made a session about the optional class, how important it is. So to get a value from the optional object, we are having a predefined method called as get method. So what it returns? It returns employee object now. So that is what about the find any method. Okay, so let's see here. I'm printing the employee object, what is written by the find any method. So let me execute now. So it's a very simple. See, if you see here, you got employee 6 information. Here it is. How many objects you got? Only one employee object. So find any will return any of the value from out of all values available inside the string. Okay, fine. So now let's move to the another method called as find first method. Now it is just simple and similar to find any. So what it will return? It will always return first element of the stream. First element of the stream. So that means what is going to happen here it is. So when you are having list of objects and from that you are creating a stream, right? You are creating a stream, and from that stream, for example, assume this is the one, this is the second employee, third employee, fourth employee. Here you have second, 4, something like 3, 5, 1, something like that. So it will return always which one? First element. So that means it will return always which one, which method? Find first. So here the method is all about the find first method. So it's all about find first method, and it will return always second one. So it's all about first one from the string. But when it comes to find any, what is going to happen? Find any method is going to do what? It may pick up any value. So there is no guarantee which value it will be pick up. We may get this value, or we may get this value, or we may get this value, or we may get this value. But find first is always returns the first value from the string when you are doing, okay, the operations. Here it is. When you are doing the operations, it will always return the first value. So that is the difference between find any and find first methods, and it is being asked in interviews also. So let's see. Now, is it returning the first element of the stream or not? So generally, whatever the order we have as part of the list, collection object, based on that it will take first element in the stream also. So 6, employee 6, right? So let me print it now whether it is true or not. So here I'm not writing entire logic, I'm just copy pasting and I'm using a method called as find first method. What is that method? Find first method. Okay, so I'm just reusing the employee object now. So let me return it now. See here, you got what? Employee 6 as a first one. So that means first element you got, here it is. So that means find any may return first value also or any other value also, but find first will always return first element of the stream. Okay, so simple, okay, and straightforward. Now similarly, let's move to the other methods what are popular inside the stream API. We will try to understand now. For example, there is one more method called as sorted method. So it's the most important or one of the important method out of stream API. It's being asked in most of the interviews with respect to sorting the values or sorting the data of collection values. So sorted methods, the method itself representing, it's all about sorting the data. So what is the purpose of this method is somehow we are going to sort the data. So how we are going to sort the data, here it is. See here. For example, my requirement here it is, I have to get employee IDs in sorted order. Okay. So if you see here, you have an employee IDs 673 in a, okay, without any order, right? So now I want to make sure 1, 2, 3, 4, something like that in a sorting order, I have to get the employee IDs. So how it is, how can we do that? Let's see here. Okay, for example, what first thing is, yes, again employees object, employees dot create the stream object. It will create stream object with the employee instances. First, what is our requirement? Sorting employee IDs. So here we know that this is all about stream of employee objects. So here map method, that means from the employee objects, what we are trying to do, we are mapping, we are getting employee IDs. From employee object to employee IDs, we are mapping. So that means now this map method will return one more stream object. Guess what it is? Stream of employee ID values. That means the data type is what? Generally employee ID data type. If you see here, integer, right? So it's all about internally the stream will contain integer values. So this is all intermediate method. Now let's call one more terminal method. Okay, what we are discussing? Sorted. Now there are two methods available. One is sorted and one is sorted with comparator parameter. So we will see second method. Okay, first let's discuss about this default parameter sorted method. So here what sorted method is returning, just observe here, the return type of sorted method is again stream of integer values. So why integer? Because map is returning already integer stream. So from that internally it is sorting the employee values. So that means before the sorting method, the order is something like this 6 comma, okay, based on this order 6 7 6 comma 7 comma 8 comma 3, something like that. Now after the sorted, what is going to happen? Internally the stream values will become 1 comma 2 comma 3 comma 4 comma 5, like that, until the values will be sorted. Now from this what you can do? Now you can collect the values like as to list, or you can collect the values as a array of values also. So I'm collecting the values as a list. Yes, then what is the list value you will get? List of integer values, right? Sorted employee IDs. So see here, everything is good or not. So here you have to use a different variable name because emp is the variable we already used as a local variable. So that is the purpose. We got the compile time error. Here it is. Once a local variable is defined like this, we should not use those variable names again as part of the lambda expression implementation point of view. Let me print now the sorted employee IDs. Everything you got in the order or not, we will see here now. See, now you got everything in the 1 2 3 4 order. For example, if you don't have sorted method, okay, and let's print the same execution one more time. See, now you got an order in the 6 comma 7 comma 3 comma 8 9, like that, right? So you understood the difference of sorted. Okay, yes, it's just applying the natural sorting with respect to the stream values when we are having. Now let's move to the another method, again sorted only, but with respect to comparator. what it is with respect to comparator argument. So we have one more sorted method with comparator argument, right? So what is the behavior of this comparator when you have to use this comparator argument as part of the sorted? We will try to understand. So this is also one of the most important topic or interview question with respect to comparator. So see here, what is the requirement we can take and how can we implement this sorted operation with comparator argument. Okay. For example, let's take a requirement like this. So the requirement here it is, define sorting based on employee IDs, sort employee objects. So that means internally, now generally when you are printing the, when you are printing the employee objects from the stream without sorting, you will get in the same order. Thus, the elements in the same order. But what I have to do now in this case, I have to sort the employee objects with respect to employee ID. That means now in the stream level, once the stream is formed from this list, so what I have to do now, I have to get employee object, this employee object first, and then this one will be second, and this one will be third. Like that, this time I am going to get the entire employee objects. But in the previous requirement, we taken what? Only employee IDs. So that means from the employee stream, we extracted employee IDs and on that we applied the sorted. But here, now I should not extract employee IDs. By using employee IDs, I have to sort employee objects itself. I have to sort employee objects itself. So how to do that? Let's see, here it is. First thing is, what is the source? Employees list. Okay, from that you are creating stream object. Okay, yes. Now let's come back to the method, sorted method. Why I am not calling any other map all these things? Because I don't want to map. I want to sort only employee objects based internally with respect to employee ID. So this is the list of objects, right? 1, 2, 3 something, whatever the order it is. From this you are creating again a stream. So assume you are having objects in an order like this: employee 6, employee 7, employee 1, employee 2, employee 10, like that. Assume you are having in a unsorted order. Now what I have to do, these are all what, guys? Employee objects. I have to sort the entire employee objects based on the employee ID, and I have to collect finally the result in the sorted order, right? So here also in the list also you have unsorted order. Now when I am collecting the list right now, what I have to do, I have to make sure in the first position first employee object, second position second employee object, third position third employee object, like that. I have to collect a list of employee objects. So this is what the requirement I have to do. So in this case, what we are doing, we are using sorted, and with respect to the comparator argument. So what is the comparator argument? I'll try to give you a small overview now. So let's go to here code. So I'm just calling sorted of comparator. So what is the comparator? Here it is. So I'll give you the overview of comparator. What is the meaning of comparator if you see here? So what is the comparator, guys? Here, if you observe here, what is the comparator? Generally, it's a part of our java.util package. It is from our previous Java versions also. Generally, comparator we will use for comparing the values. For comparing the values to come to. So that means most of the times we will use comparator in the sorted operations before Java 8 version also. We have one abstract method called as compare, and we will try to implement some logic for this abstract method. Now what that means, comparator is also a functional interface. So that means as part of the sorted method, now what you have to provide implementation for this comparator functional interface, and the method is called as compare method. It is going to return internally integer value. Based on that, a sorting operation will be carried out. So please refer the comparator details. So if you want more knowledge about the comparator. Let me call this sorted with respect to comparator, and internally it contains only one abstract method, and it is taking two values, two method arguments, right? So I'm taking employee 1 comma employee 2. Out of employee 1 comma employee 2, so I'm implementing lambda expression implementation here again. So if you see here, even dot. Okay, I will do one thing here. Now let's see here how I am implementing. Return even dot get based on what we decided, employee IDs, right? Sorting based on the employee ID. That's why we taken it is. If you taken a based on employee salary or employee's age, then you have to use those values. Here it is minus e2 dot get employee ID. So we are just based on this comparison, we are making the values. Now what sorted method will return? Again, a stream of employee objects. That means internally now this stream will be sorted with respect to 1, 2, 3 like that, and again you are going to get one more stream on instance from this operation. So that, and from that what you can do, if you want, you can collect it as a to list also. So you can collect it as a to list. So see here, now what is the values you are going to get? List of employee types. So let me hold the return value. Let me define sorted employee objects. Sorted employee objects. So sys out of sorted employee objects I'm printing. See here now what you got, employee ID 1 and followed by employee 2 and followed by employee 3. So you got in the sorting order based on the comparator implementation. So please refer more about the comparator, the most important with respect to interviews. This is the most favorite topic as part of interviews for so many panels. So please go through it with respect to sorting objects also. So now let's move to the one more method as part of the stream API we will see now. For example, I have to get minimum salary employee details. Out of all the employees, whoever is having minimum salary, those employee details I have to get. So I have to get minimum salary employee the details. So the functionality is what? Minimum of salary of, and that employee details we have to get it. Okay, let's create the employees. From the list we are creating the stream object, and from that stream object let's see what is the method we have, guys. Minimum method, min method with comparator argument. So comparator is again similar to the previous method only. Okay, so based on what? Salary this time, right? So let's implement how we are going to do the min method with respect to salary. Here it is. Okay, so let me do like this. So what you have internally, so comparator is having internally compare method, right? We already saw it. Functional interface, it contains compare method with two types of two argument values, right? So employee 1 comma employee 2, two arguments as per the abstract method. Okay, and I am providing implementation now, like even dot get, what we are worrying, guys, salary, right? Minus e2 dot get salary. So based on this, I have provided comparator functional interface implementation with okay, by using lambda expression. And from this, what you have to do? So what is the minimum method is returning? Optional of employee object, optional of employee objects. So that means from the optional element, from the optional object, if you want to get the actual employee object, so from that optional container object, if you want to get the original employee object, we have to call the get method. Now what get method is doing? Employee information it is returning. So see here, employee minimum salary employee data, right? Let's do here, typecast it to integer, for example, to avoid this problem. So what is the problem? Simply salary is the double value, right? Double minus double, it is returning double value. So but it is return type of compare method is integer method. So that's why it is giving the compile time error, and we typecast it to the integer value, so that no problem. Now let's print it. Who is having less salary? System.out.println. So what you got? You got the minimum salary employee. Who is that person? Employee 6. Who is having 9,500 only. Yes. True or not? See. Yeah. If you see here, yes, this guy is having only 9,500 salary, and the remaining all people are having more than 9,500 salary, right? So this is all about the min method with respect to comparator argument. So that's why we have to understand what is comparator compare method very clearly. So please refer one more time. So now let's move to the another method. Similar to minimum method, min method, we have a method called as max also. So if you want to find out max values, from the stream elements. So we can use max method. So it is completely similar to min, but opposite to the min functionality. Like we are going to get the maximum value out of all the stream elements. Okay, max salary employees. I'm just applying max method. Here it is. So the functionality is same, guys. Internally it will compare employee 1 salary and employee 2 salary. And here now this time it will give priority to the maximum salary employee, and based on that you are going to get finally who is having max salary out of all the employees. You will get that employee details. We are just getting maximum salary employee details. So let me print it. So see here we got the maximum employee salary or not. So see here we are getting maximum salary employee or not. We will see. Employee 8 is having salary called as 34,500. So let's see anyone else is having more than that to represent the functionality is working as expected. So if you see here, there is no other person's salary is greater than 34,500. So in interviews also they will ask you like how to find an employee details who is having maximum salary, okay, or minimum salary. Like that they will ask the questions. Then you have to write down this kind of implementation. So let's move to the next method. There is one more method available called as average method. Method name itself telling the functionality of this method. So what it is, getting the average of the values. So that means once we are applying average on stream object, then it will provide you the average value out of all the stream elements. Okay, so you know that generally we will calculate average on numeric values, right? So what is the requirement here? It is, for example, to fulfill this method, I will take a requirement like this. I would like to find average salary of employees. So that means out of all the employees, I would like to find out. So what is the average of all the employee salaries? We will find out. So see here, let's take the source, nothing but the original list object, and then you are creating a stream object. Okay, fine. And then from that, what you want to find out? Average of salary of all the employees, right? So let's map first to the salaries from the employee objects. So for that, what I'm using a map method. And if you observe here, there are a couple of other map methods also. If you see here, map to long, map to int, map to double, map multi to long, something like that, right? So functionality is almost the same, but only thing is parameters are going to change, depends on the requirements, or sometimes when we are extending the implementations or solutions, we have to use couple of utility methods provided by the stream API. So in this case, for example, I'm taking here. So what it is going to take internally, two double functions. So that means similar to function, we do have functional interfaces called as two double function. It is going to deal only with the double values. So I'm just taking this. That means this is one more method I can call map to double, but it is functionality similar to map method only. So what it is going to do, it is going to take employee object. So you know that functionality of functional interface, right? So it will take input value and it will give a return value always. So from this, what I'm going to get, I'm going to get salary, because salary is a double value. That's why I taken map to double here. So now it will produce all these salary values again as what, a stream of the objects. So that means now one more stream is created. Once this method will be executed, a stream will be created with the values of salary, right? So yes, see, double stream salary. So what is this double stream? Yes. So similar to stream, we have couple of other stream interfaces called as into stream, double stream, like that. We will see one small example related to other stream interfaces what we have along with the stream. Simply, now this is representing, okay, the stream will always contains only double values. So that is what about the double stream. Here it is. So now from this we are going to get average of the salary. See here, I'm calling out average method and it is returning optional double. So we do have categorized optional classes related to double and other data types along with the generic optional class. Okay. So here what I'm doing, I'm just calling get as double. So that means it is going to return always as a double value, this method. That is what the meaning here it is. Okay, so here let me take it as employee. So see here, average double average salary. So let me see the result. If you see here, you got the overall average salary of all the employees. So what we learned now, newly the map to double method. We are extracting all double values and finally you are getting double stream, right? Similarly, we do have other methods called as map to int and one more is map to long. So that means we are going to map values to the respective integer and long stream values. So if you see here, we have double stream, int stream, long stream, right? So that is what, when you are using map to double, you will get double stream result. If when you are using map to int, then you will get return value as integer stream. When you are using map to long, then you are going to get long stream. So specific to these three data types, specific stream objects we have. When you have other data type values, then definitely we have to use this map method and you will get any kind of return value and you are going to take stream with respect to the data type values. So now it's all clear, right? So whenever you want to map from one type of data to and other type of data, or you want to extract the values, and if it is belongs to the integer, then you can take map to int. And if it belongs to the long data type, that means the return value becoming whether it is a long data type, then you can go with the map to long in this place. So here salary is double data type, so that's why I used map to double. In case if it is map integer value, then I can take integer like that. Okay, so if you want to find out average age of employees, then what you can do, simply map to integer employee hyphen, so employee representing the overall employee object. From that you are extracting employee age and finally you can call the average method. Okay, so I'm just reusing the logic and what I want here, get age, right? So age, so what we are trying to find, average age of employees, right? So age, and what you are going to get, age you are going to get always, average you are going to get always in the double value, that's why you got here. So you are getting always optional double. So that means average method will always return double, optional double data type. So from that you will always get a double value because we know that average will always provide the decimal values. So let's see here now, double average age. So if you are taking here, sorry, I forgot to take here, right? Average map to int. So right, it is what? Integer value. As part of this mapping, we are getting integer value from the employee object. So what it will return, see here, int stream. So that means similar to stream only, but only thing is this stream will allow, or the stream contains only integer values, not any other data type values. Similar to double stream, double it will allow only stream with double values or contains double values. Here it will contain only integer values. Now from that, if you are calling the again average method, so it is going to return optional double and you are going to get result as a double value. So I can take now double, okay, average age. Okay, let me print it now. See here now, let I got result what? You got 29.9 here. Okay, so this is how we can use map to double, map to int and map to long along with the regular map methods. Map to int, map to long, map to double will work only with the data type of long, integer and double respectively. So I'm not taking example for map to long because it is similar to these methods only. Now let's move to the another method which are being popular again as part of the stream API. So now as part of stream API, we have a method called as peak method, and this is a special method as part of stream API, and we have an interview questions around peak method also. So what is the importance of peak method? What is the functionality of peak method inside the stream API? We will try to understand now. So if you see, first of all, the definition of the peak method, okay, employees dot stream. I'll just show you what is the definition given by the stream API for the peak method. So what exactly it is? See here, peak method is taking method argument of consumer type, and what it is going to do, returns a stream consisting of the elements of the stream, additionally performing the provided action each on each element, okay, are consumed from the resulting stream. So that means, for example, assume this is what a stream object which contains employee objects, right? So it is a stream object, internally it contains employee elements, and from this employee type stream, whenever I am doing any other operations on the employees type stream object, I will get resulted stream objects, right? For example, if I'm done map operation on this stream and I'm collecting all employee IDs, then what will happen? Map will produce from employee object to employee ID values. Again, a new stream will be created with employee IDs, right? But now, as part of process, from one stream operation to another stream operation, okay, what is being processing, and at the same time, every value has to be okay involved as part of some. So that means here the peak method is simply saying like it is going to perform an activity, okay, it is going to performing an action on each element what is received by this stream and what you are processing to the next operation, okay, from this stream. So it will perform an action on each and every value, and then the respective operation will be done, and the respective operation functionality will be executed. So this will be repeated for each and every element available in the source stream instance here. So that means what is going to happen here, it is, if you see here, for example, I have a requirement like this: find out who are joined after 2015. I have to find those employee objects. So in this case, that means first is what we will have, guys, we will have a list of objects, right? So these are all objects inside the list, and from this we are creating a stream. So here we are creating a stream, and internally again it will contain all employee objects. So from this stream, now I am applying an intermediate operation called as filter, okay, like greater than 2015. The joining is here is greater than 2015 I have to get, right? Call a terminal operation called as toList. Finally, I'll get the list of employee objects who joined after 2015, right? But now in this overall process, so here how many objects we have? 10 employee objects. So here how many we will get? Probably less than 10 or 10, right? So it might be 0 also, 10 to 0. So it is all, there is a chance you are going to get 0 to 10. In worst case it is 0, or maybe maximum 10 values you will get as part of here it is, in case if everyone joined after 2015, right? So now I want to trace here, I want to perform some action. On each element. I have to perform some action, okay, and then I have to process that element to the next filter operation. So that means when this element is processing by this, okay, before filter method, so I have to take that element and I have to do some action on that element, okay, as part of consumer implementation available inside the peak method. And then again I will process same element to the filter method. So that means here what is happening, you are doing an action on the element, but we are not managing or manipulating this object, and we are passing that object as it is to the next filter method. So like that every element will, okay, do same action, second element do the action and process it to the filter. Now third element came, okay, perform the action and pass it to the filter method, Similarly, fourth element, perform the action and pass it to the filter method. So like that, in between any stream operations, when you want to perform an action, and that action will not impact the actual stream object or the stream elements, and when you are processing with other consecutive operations, stream operations. So let's see here. So generally that's why peak method will be used in the most of the cases as part of tracing. You can do the trace or you can perform an action. So any other actions on the element, every stream element. But this process will be repeated for every element, like okay, take the element, perform action, process it to the filter. Take the element, perform action, and then process that element to the filter. Like that, for every element, same process will be repeated. So in between any operations, if you want to perform an action without impacting the source and resulted streams, then you can use the peak method. So let's see a requirement here and how can we implement it. So now my requirement here it is, out of all employees, I have to find whose date of joining is greater than 2050. Okay, those employee details I want. Okay, and at the same time I have to track, okay, how many employees, okay, how many employees are processed. I need this track also, how many employees being processed. So see here what I will do. First, list object, you created stream, and then from that I'm creating a peak method. Okay, as part of peak, what is the implementation we have to provide? Consumer functional interface implementation. So consumer will take a input, but it will not return any value, right? So what I'm doing, I'm just printing all the values, system.out.println. Okay, so that means whatever the elements available inside the stream, okay, it has to be printed before processing to the filter method. So that is what my idea here it is. Okay, filter and predicate is all about what? So this is contains what? Employee objects, right? So that's why employee hyphen employee dot what we were looking for, get data year of joining, and those should be greater than 2015, right? And then I have to collect those list of employees. So in this case, what peak method will do, we will try to understand. So let me do one thing, list of employees, employee details, something like that. Okay, so let me print it now, sys out of employee details. Okay, so here I'll write down a line separator to differentiate peak methods. So see here, let me execute the applications and observe what's happening. So if you see here, from here the method execution started, right? So what's happened now? Stream with 10 employee objects, and yes, first employee 6, employee 7, employee 7, employee 3. Like that, it is processed, okay, all the. So that means it is very clearly saying from the stream, first employee object given to the filter, second employee from the stream, second employee object given to this filter. Like that, you given the values. Now, for example, see here, I am taking peak method from here to here. Then what will happen? Guess. Now in this case, you will have how many employee objects? 10 employee objects. Okay, the stream contains 10 employee objects. But in this case, now once you are doing this operation, how many employees you will get? So probably either 0 or 10, 0 to 10, right? 0 to 10 objects. And where maybe whatever the result you got after this filter with respect to employee method, employee objects of stream, okay, and I want to see finally what are the values being finalized and what are the values being terminated. What are the result I am making as a list, converting as a list, I have to see. So that means in such case, what is the value processing from the stream object, okay, and processing to the toList method, those values will be printed now. So see here, it is printed 6 and 9. Why? Because from the out of the 10 employees, we have 2 employees, okay, joined greater than 2050. So then, okay, who is that? 6, 8. So now it is saying like from the filter, it is having 2 employees. Those are all, okay. Who are those employees? 6, 8. So 6 record is passing 6th employee object processor to the toList. That is what done by the peak method. So that means every value of the stream result before passing to the another operation, okay, we intermediately we are performing an action, or maybe we are doing some kind of tracing implementation and what are the values being processed from one operation to another operation. So it will be repeated for every element. That's why you can see this time too. In earlier case you saw when we applied peak method here 10 times every employee object is printed with different employee objects. So this is how we will use the peak method. Okay, peak method will take internally argument as a consumer. Consumer will not return any return value. So that's why we will not write any filter conditions or mapping conditions with respect to peak, because finally it will not return any value. That's why you should not use. So what peak method will return? So peak will return the element, one by one element from the attached source stream object and processing to the next operation. So that is all about the peak method. Now let's move to the another method called as, so this is all about the methods as part of the stream API. So we are covered almost every method including intermediate and terminal operation. We do have a couple of other methods also somewhat related with one class called as collectors class, and I will discuss that right now. Okay, so before moving to the collectors class and collect method or something, there is a method called as reduce also. Before moving to that, I would like to give you one more point here. It is generally, as of now, we created stream instance from the list n number of times. In the same operations class itself, probably we have created stream instance everywhere, right? Employees.stream, employees.stream, employee.stream. So that means in this case, whenever we created method called as stream method, right? So whenever we are calling a method called as stream method, what is going to happen here? It is internally it is creating a sequential stream object. So that means sequential means, you know, right? One by one value. One by one values will be processed by the processor or internally. That means when I have a list of objects here, and from this list of objects, I created this stream. So whenever you created a stream, what will happen here? It is the values will be available inside this stream, like object 1, object 2, object 3, object 4, object 5, object 6, like that. And whenever you are performing any operation on this stream now, any operation is performing on the stream, what will happen? The operations will process the elements one by one. So that means first the operation will apply on this one, and then second this one. Okay, a single thread kind of, okay, a single process is working like that. So first process this element, and then second, and then third, and then fourth, and then 5, like that the operations will be carried out, okay, in a sequential manner. That is what the sequential stream. But at the same time, stream API provided one more way to create the stream object, that is called as parallel stream. What it is, guys? It is all about parallel stream. So that means whenever from the list of objects we can create stream object in two ways. One is sequential stream and the second one is parallel stream. So by default, whenever we are calling dot stream method, so what is that method? We are calling dot stream method, right? So it is all about stream method. Now similarly, we have one more method called as parallel stream method. What is that method? Parallel stream method we have. So if you are calling parallel stream method, internally the stream object will be created in parallel stream. So in previous case, it is returning sequential stream. So that means by default, you will always get sequential stream when you are calling stream method. Now, but when you are calling parallel stream, you are going to get parallel stream object. So now, what is the difference between sequential versus parallel now? Okay, now for example, if you created sequential stream or parallel stream, then what is going to happen here? It is, so as part of sequential stream, this is going to happen. The elements inside the stream will be processed one by one. This is stream, right? So whenever you are doing any operations, one by one value will be processed in sequential manner. It will follow an order. Okay, but when you are calling parallel stream, that means when you are created stream with parallel stream method and you created parallel stream object, what is going to happen internally here? It is, as part of the stream internally whatever created, okay, assume this is a stream you created, right? So here the objects you will have. Now internally they are going to segregate your stream into multiple, okay, sections, and one by one Okay, process internally we computer processors will have some cores. Okay, so simply I can say like assume like this way. Okay, a thread is operating on this tree and one more thread is operating on this and one more thread is operating on this. So that means now if I'm calling any operation like filter method, okay, or map method, what is going to happen? Thread 1 will perform filter on these values on its own. Okay, on its own the filter will be executed. That means the operation. Similarly, thread 2 parallelly, that means thread 1 is started its process. Now parallelly thread 2 is also processing its status. So that means the same operation is being done by the thread 2 on this set of elements available inside the stream. So this is what stream, right? So that means parallelly the thread 2 is processing its operation. Similarly, thread 3 will start its execution on the operation of this section. So that means what is the final thing here? It is when you created parallel stream object, internally the multi-core processors will start executing, or the stream will be divided into multiple sections and each and every section is processed by each and every multi-core process, or we can consider it as a thread also. Then parallelly threads will start executing same operation on stream elements. So then which one is better option, whether it is a stream or parallel stream? So here stream may take some time when it comes to the performance point of view. Stream will take some extra time when comparing with the parallel stream, because stream is all about processing one by one value sequentially, like this. But parallel stream is all about processing values based on the operation parallelly by dividing into multiple sections and by using multiple processes, right? Then parallel stream will take very less time to perform the operations when comparing with the sequential stream. Okay, if you see here employees, so from employees I'm creating which this time parallel stream. So when you are creating an object with parallel stream, what is going to happen? Internally it will create parallel stream object. But what is the difference between which one we have to choose here? It is parallel stream sometimes may not guarantee the order of processing the elements, but sequential stream will guarantee the order of elements processing internally available inside the stream object. So that's why most of the cases people will try to use sequential stream to do any operations instead of parallel stream. But in case if you want, you are not worrying about the order of the elements being processed or whatever it is, then even we can utilize parallel stream, so that parallel stream will take very less amount of time to do all the operations on stream pipeline, whatever you concatenated. Consequently, when comparing with the sequential stream, it will take less time. So let's take a small example with respect to parallel stream. So whatever the methods or operations we discussed till now, like with respect to the above all methods, terminal or intermediate methods, are similar applicable for this parallel stream also. Only thing is internally multiple processors will work on the same stream object by dividing into multiple sections. Parallelly elements will be processed by dividing into small groups. So that's why it is being called as parallel stream. So what I will do here, I am not taking anything. So I will implement the above, just this functionality with parallel stream. If you see here, what I will do, so here let me write down sys out of parallel stream. Now I will write down this logic as it is, but only thing is I'll call parallel stream method. So here instead of stream, what we are calling this time? Parallel stream. Okay, so if you see here, there is nothing changed. I am processing parallel stream. So here now we will observe the difference between the order of elements processed from the stream in this operation, sequential as well as parallel point of view. We will try to understand right now. So here I used parallel stream. Now if you see here, peak method point of view, you got an order 6, 7, 3, 8, 9, 10 like that, right? So if you go to the actual source of list object, what is the order? 6, 7, 3, 8, 9, 10 to something like, right? So that means sequential stream will follow same structure internally. I mean, when you created stream instance from the list, internally, okay, stream is also maintaining the same order as part of the list. But when it comes to the parallel stream, see, there is no guarantee of the order. Okay, that is what I told you, right? So it is processor 2, it is processor 10. So there is no guarantee which order you are going to get. And then 3 and then 5. So okay, 2, 10, 3, 5, right? So let me execute one more time. So see here, 2, 10, 5 this time you got. There is nothing like 3. So there is no guarantee of order. But in this case, every time you got same order. Every time you got same order. Okay, so this is all about the parallel stream. So you can create a stream object into two ways. One is sequential and second one is parallel stream. So if you are calling stream method, it will create internally sequential stream. One by one value will be processed by the operations. If you are calling parallel stream method, then internally it will create parallel stream, and whenever you are performing any intermediate operations or terminal operations, internally multi-processes will start processing your stream elements parallelly by dividing into small group of elements. So this is all about the parallel stream method to create the stream instance. Okay, total two ways we can create. One is either sequential stream or parallel stream we can create. So now let's move to the most important method called as collect method from the stream API. Before knowing specialization, like we have a class called as collectors class. Okay, this class will be specifically used as part of this collect method inside the stream operations. So, and this class is also introduced from the JDK 8 onwards to support, I can say, like stream API operations. So that means we should know first of all little bit about the collectors class, and then only we can understand the collect method. This collectors class is giving a lot of utility functionalities with respect to data operations on stream instance. Collect will comes under the terminal operation, and what we are going to do with the collect method, and internally it is involving collectors class, and what collectors class is providing, we will try to have some examples right now. Okay, so now let's take discussion about the collectors class. So generally collectors class is a simple utility class provided utility functionalities or utility use cases what we will use daily basis in our application programming to collect values from the stream instance, or to accumulate values from the stream instance to any collection type values or aggregated functionalities, or maybe grouping functionality or summarizing functionality point of view. The collectors class is provided by the Java language. So that means as part of the collectors class, we have a lot of collector methods, and each and every method is going to represent one kind of functionality. So what we can do with the stream elements. So that means whenever we have a stream and whenever we want to accumulate the stream elements with respect to a collection object, then we can use a method called as toList method from the collectors class. Like that, we do have some other functionalities like averaging functionalities, summarizing functionalities based on the all stream elements, or we want to group the stream elements based on a property. So all these use cases or utility cases are provided as part of the collectors class as a static methods inside the collectors class. So if you want to see here, the definition of collectors class is all about what they are saying. So it's just like a implementation of various useful operations such as accumulating elements into collections, summarizing, and according to the different various use cases and criteria. So a couple of examples they are saying as part of the collectors in class itself. So this is a collectors class, final class, and it is also introduced from Java 8 onwards only as part of stream API introduction. If see here what they are explaining about the collectors class, they are also saying like when you are having, so a couple of use cases they take in here, it is accumulate names into a list. So that means assume you are having a list of tuple objects, and from that you created stream on instance and you got only names from that tuple object, and then you are making a new list with that names what you are mapping from object to name, and every name value is finally mapping to the list. I mean, you are collecting everything as a list of values, like what we did in earlier functionality. Instead of using collect, now we have a shortcut method directly called as toList. collect method. So this is also one more approach. This is also one more approach. So if you want to accumulate names into tree set, yes, map to the names and collect values as collectors dot to collection, and as a tree set object you want to collect all these values. Here as a list you are collecting all these values. So what you are doing here, you are calling a method called as collect terminal method, and inside that you are using collectors implementation as an argument, and you are calling all the static methods of the collectors. Depends on the criteria, depends on the functionality. If you see one more use case they are taking, like convert all the strings and concatenate them with a separated by comma. So that means from all the string values, for example you have objects, you created string and you are mapping all the string values, and then you are collecting all the string values concatenated by the comma. That means finally you are going to get a full length string which is concatenated with all the string values with comma symbol. So like that you do have other use cases here also. So we will see a couple of use cases in our employee objects right now with respect to collectors class and collect method. So simple, collectors is a simple utility class or provided utility methods to fulfill a lot of common use cases. If you go here, collectors class is having a lot of predefined utility methods. What it is? Averaging to double. So that means all the values will be averaging to the double. Similarly, averaging to the integer value, averaging to the long value. The count, what is the count of the stream elements, like that. Grouping by, so we will see functionality right now about the grouping. Joining, so what you are going to join, so joining with some char sequence. Right now we have an example, right? So separated by comma symbol, like that. So whatever the symbol you want to separate, and you can join all the string elements, something like that. So max by, minimum by, so summing into, summarizing. So these are all methods. If you see here, to list, to map, to set. When you want to accumulate values as a list, to list. If it is set, to set. If it is map you want to accumulate, then you have to form a map from the stream elements, then you can use to map method also. So let's see here what you are going to do now with couple of methods inside the collect method by using collectors class. So let me implement couple of requirements. For example, collect all employees names whose age is greater than 25. So I have to collect this one. So simply we know that, right? First you will have collections object, that means employees dot create the stream object, and from that filter the employees who is having age greater than 25. Employee dot get age whose age is greater than 25, those employee details you want, and from that map, and what you are collecting, their names. You are collecting name, right? And here what is the requirement? Collect all employee names whose age is greater than 25. Collect all employee names as a list, as a list. Okay, this is the requirement, right? Now I can use collect method here. Okay, and from the collect method we are going to use always, most of the times, the class called as collectors. And if you see from the collectors class a predefined method, to list, right? So to list we are using. Now what is it, what it is going to give you? It is going to give list of string values, because you are mapping finally to the string values and everything is collected as a list. Employee names, right? So let me print it, sys out of names. See here, so you got all the employee names or not? Yes, we got respective employees whose age is greater than 25. But this is the approach from Java 8 onwards. But in Java 16, even they simplified this operation. They given direct method called as toList also. So like we discussed in the previous example, we can directly take toList also. Okay, so it's all about our comfort or what Java version you are using. If you are using Java 16 or greater than, then you can directly use the toList. If it is below Java 16, if you are working for Java 8 and 11, then you have to go with this approach only. Directly calling toList will not work out, because I am going with the Java 17 as part of this tutorial. Fine. So this is how you are going to use the collect terminal method. So it is a collect is what? A terminal operation only. Please remember that. And collectors is a utility class providing utility methods, all static methods. Okay. In such a way, we can simply wrap the result based on our requirement. Okay. Let me take one more requirement and then we will try to use collect method and collectors class also. So my requirement here it is get unique department names. Okay, what I have to do. So from the employees object, I have to get the unique department name. So see here employees dot stream, first create the stream object, and from that what you have to do, map the department. First of all, identify what are the departments available, employee and department, right? So from the departments, what you can do, you can make the distinct. This is one way, right? So it will pick up all the distinct values and then you can call something like toList, all these things. Or else, for example, so that is what guys, it's all depends on the scenario analysis, our skill set, what kind of solutions we are using. So sometimes same problem will have multiple solutions. So instead of distinct and collecting as a toList, for example, if I take in collectors dot to set, what I've just connected as a set. So what is the set nature? Set will not allow duplicate values, right? So that means now what it is going to return, if you see here, collect method is returning, the terminal method is returning set of string values. So this is also you can write down instead of distinct and tooling. So if you see here departments, sorry, it's all about set. Okay, let me print it now. So see the departments, what are the departments available from the employee objects, we got all these details. So we have sales, finance, and as well as infrastructure, HR, and security we have, right? So we have all these departments. So this is how the collectors class is helping us to accumulate the results from the streams, and we are wrapping the stream operation or stream pipeline with the result. Okay. So I will take a couple of other methods also, which are more popular as part of the collectors class. So for example, I'll take one method with respect to map also. So for example, I'll collect employee IDs and their salaries. So that means my requirement is here it is what guys, I have to collect employee ID as a key and their respective salaries. As a hash map I have to collect employee IDs and their salaries as a map. So what I have to do? First thing is, yes, go to the employees list object and from that create the stream. Okay, then it will create employee stream. And then from that, what you can do, you have to take the collect method and now see here collectors dot to map. So what is that? To map method. So map will contain always two values, right? Key comma value pair combination. So for that, so here you have to pass two values and one is collectors dot and one is what is that you would like to collect employee dot, here I am using simply method references or you can directly write down employee dot get also. So lambda expression notation also. Here what is that? ID, right? Get employee ID. So instead of lambda expression notation, I'm simply writing method references. So please refer method references also one more time to understand all these functionalities, and it is very important. I already made a session about method references also. So here, and what is the next? Employee colon method reference, and what is the values you are collecting? Salary, get salary, right? So that's all. Now see what is the return type of collect. It's all about map integer comma double. So why it is map integer comma double? Because employee ID is an integer data type, salary is a double data type. That's why it created map with these data types. Okay, employee ID and salaries. Okay, import the map. Okay, so let me print it now. So we got all the respective IDs and salaries are not. We are trying to understand now. So see here, employee 1 25,000, 2 13,500, 3 18,000, like that. Every employee ID and their respective salaries we got as a key value pairs and we collected it as a map. So this is how the collect method is making our life very simple from the stream of elements. Okay, so let me take one more method also. So the most important here it is grouping by method. What it is? Grouping by. So what is the meaning of grouping by? So somehow group by functionalities. It's all about group by functionality, like how we will have in our SQL language also, right? So we have a group by functionality, right? Same kind of here also. I want to calculate the average age of all male employees. I want to collect all female employees average salary. So here I am grouping based on the gender, right? These are all the examples. So in such cases, you can use the grouping by method also. Okay, grouping by method from where? From the collectors class. The methods what we are discussing is completely from the collectors class, and that we are being used inside the collect method. Okay, now let's see a requirement to utilize this grouping by method also. So my requirement is get average salary of each department wise. I want average salary. So then what I have to do? First, the actual list object, and from that create the stream object. It will create employee stream objects. From that, what you have to do? Collect. So here somehow we have to use the grouping by method, right? So how to use it? We will see now. So if you see here, collectors dot grouping by, okay, you have a lot of, okay, what overloaded methods from the grouping by method. So you have something like function and as well as collector, supplier, implementation. So I'm just trying to take example for one of the grouping by method to achieve this requirement. So what you want guys here, okay, let me do one thing. Let me close here. So here you have to implement the grouping by functionality. What you have to group? You have to group the department, and based on that you have to make the calculate the average salary. So what you have to do group? So what you are going to grouping here, employee, based on the department wise you are grouping. And what you want again from that grouping, you want, see here again I am using the collectors method to make it as averaging. If you see here, averaging double, averaging integer, averaging long. Now what you are trying to averaging from the employee object, you are averaging what? Get salary. So now that means what is the point here? It is grouping by method is saying like group the values based on the department, and which values? Salary values, and find out the averaging. Find out the average of all these values based on the department. Now see what is the return type of collect method? Map of string comma double. So why this is return type? Because string is all about department name. Double is all about average salary of each and every department. So here average salary department wise, right? That is what you got these details. So see how Stream API is making, now just realize the importance of Stream API, how it is making simplified solutions when comparing with the regular old solutions. Like for example, if you want to achieve same requirement before Java 8, what we have to do? This list we have to iterate with for loop, and then we will write down if conditions. Okay, while iterating each and every employee object, we will try to get all departments and their respective salaries. Once we are identifying all those things, we will do some average calculation, right? So we will identify the count of salaries and we will make, okay, average count, average salary, and we will again create one more hash map object, and irrespective to the department name, we will set that average value. So this is all the logic implementation manually we have to implement, and it will take longer time and it will take longer lines also, right? But now here it is just like utilize the existing features, or just like fill in the blanks way they provided the solutions with respect to Stream API. So that's why Stream API got more popular from the Java 8 features. And to understand the Stream API, we should know all other Java 8 features. So to achieve Stream API understanding, definitely we should know other Java 8 features as a prerequisite. Default methods, static methods inside the interfaces, as well as constructor references, method references, functional interfaces, lambda expressions. Together, all these are helping to understand our Stream API. Now let me print the values, average salaries, run as Java application. If you see here, you got all the employees, all the salaries related to the department wise. Average salaries of every department. Sales, you got the average salary. Finance department, yes. Development department, yes. Infrastructure, HR, security point of view. So these are all questions being asked in interviews, guys. They will simply ask you, can you get department wise average salary? Okay. Or department wise total salary. So like that, they will ask. If it is total, then if you see here summarizing into double, so whatever, you just use it. This is all about the importance of grouping by method. Now I will take one more method called as count inside the collectors class. So when we have to use count as part of the collectors, or just one use case we will try to understand. For example, get count of employees gender wise. So I would like to see how many female employees available, how many male employees available, count I want. So it's a very simple now also. Employees dot stream. Yes, we created the stream object, and from that I want to collect gender wise, right? So you have to collect, and here, okay, let me make it as colon here as a terminal method, but inside the collect method argument I am using collectors dot grouping by. Why you are using grouping by? Why are you using grouping by now? Because we have to group gender wise, and then we have to find out the count. Same, right? So that's why what it is, first you have to group based on the employee gender, right? You have to make sure gender wise grouping, and then what you have to group, what you have to find, sorry, count based on the gender. So now let's see here, collectors dot counting method. That's all, it's done now. Based on the gender wise you will get the counting also. So what it will return again, map, because grouping by means it is grouping based on this and providing this value. So that means key value pairs. So grouping by internally returns map functionality. So that's why you will see now again a map object with string comma long. Long means the count value. So here count of employees gender wise. So if you are trying to understand the Stream API very logically, it's very simple, guys. Please take care of couple of practices, then you can easily understand Stream API and we can easily operate with the stream operation. So let me execute now. So if you see here, female 5 employees are there, male 5 employees are there. I got the count. So this is also one of the most popular interview question involving collection topic, Stream API topic, as well as collect method and collectors class also. So these are all classes they will ask, and it is one of the most popular interview question. So now I'll take one more also. I have methods like summing, okay, summing based on double summing int summing long like that, as well as summarizing double int long like that. I have a couple of methods. So we will try to understand what is the meaning of summing, summarizing with respect to one, okay, data type method, and you can practice same thing with other data types also. Okay, so what is the real difference between summing and summarizing is we will try to understand. So first let's take what is going to happen here. I'm directly writing this time inside the system.out.println employees, okay, dot stream, okay, dot collect, okay, from that internally collectors dot summing. So first I'm taking summing. Okay, if you see here summing double, summing int, summing long, and what I would like to sum here it is, for example, I would like to sum all the salaries. What it is, employee, for every employee salary I would like to sum. So I'm just taking summing double here because I'm going to sum the overall employee salary. So here my requirement is summing all employees salaries. Summing all employees salaries is the requirement, right? So based on that, I'm taking summing double. Why I taken double? I'm summing, I'm just adding all the double values because salary is a double data type we defined inside the employee class. So that's why I have to take, here it is, employee colon. So what is that? Salary. So when whatever that argument you are taking here, that data, that based on that you have to take this. Okay, so salary. Now let me print it. What is going to happen? Are you going to get the entire sum of the salaries or not? See here, you got all the employees sum of the salaries like 2,16,007. Okay, it is just summing all the values. For example, you have a group of values, integer values or long values or double values, and you want to find out sum of all the values. Then simply you can use summing double. But what is the summarizing? Here it is. Let's understand. If you are using summarizing method, in the summing method point of view, what is going to happen? See here, summarizing double. Okay, in place of summing, I used summarizing double. Now understand the difference between summing and summarizing, how it is going to differentiate. Okay, it's all about summing, it's all about summarizing, right? Let me execute now the actual difference between summing and summarizing. What if it is summing? What you got, guys? A single double value by making sum of all these salaries. But when it comes to summarizing, generally what is the meaning of summarizing? Summary is all about the highlights or the overall statistics point of view, right? So now it is giving internally what is being happened, okay, like how many employee salaries are being calculated. That means some adding, I mean, how many employee salaries are being added one to one internally. All the summary details it is provided. If you see here double summary, so that means it is saying total 10 employees are there, okay, and it got some values. So if out of 10 employees, okay, their salaries is all about 20, sum is 21,000, I mean sorry, this one 2 lakh 16,000 and 1700, right? That is what you got in earlier case also. But here summary statics means it is giving summary, so that means summing value as well as what whose salary is minimum salary and whose salary is maximum salary and what is the maximum value and what is the average value. So that means when you have to go with the summarizing method, when you want to get all the information at a time like min value, max value, average value and sum value, then you can use the summarizing method. If you want only sum value, okay, out of all the values, then you can go with the summing method. You got the point? It is just providing summary, that is nothing but it is giving four values internally as an object, double summary statistics. It is giving count of the values, how many, okay, elements available inside the stream, and mean how many values processed and what is the total values, what is the minimum value, what is the maximum value and what is the average of all the values also you got based on this summarizing double. See how it is very simplifying our programming style or how we are making the logic implementation. So now let's see one more method as part of the collectors class. That is all about max by method I am taking. Okay, so one of the method we are being used in our project. So what is the meaning of max by method from the collectors? So the name itself telling it's all about maximum value, right? So see here, I am finding max age of employees. So that means from out of all employees, I'm trying to find the max age employee. So see here what I'm doing, employees dot stream, create the object, stream object, and from that collect. Now what is the method we are using? Collectors dot max by, right? So internally what it is using? Comparator. So we have to provide the comparator implementation like what we discussed in previous min or max methods. Okay, when we are applying on the min or max methods as a terminal methods in previous case, right? So it is now in this space you can directly use min also, or you can use directly max also. So this is again, if you see here the max method, so this is the max method, right? So here also you are providing the comparator. These are all being added latest. Okay, we can use those methods also, or we can go with the collectors, collect method and collectors also. So it's up to our choice. Okay, I'm just taking an example with collectors only, right? Max by. So what you have to provide? Comparator. You know that, right? What is the comparator implementation? Two method arguments. It will take employee object 1 comma employee object 2, employee 1 comma employee 2, and from that what you have to do? You have to make sure their ages, right? E1 dot get age, right, minus E2 dot get age. So internally it will process all employees age and it will sort internally. Finally you will get the maximum age employee details. This is way you can write down. Now what is that? You are going to get result optional of employee. So if you want you can write down dot get method here itself, so that you will get directly employee object. Okay, so please go through the comparator, it's most important. Now employee max age employee. So let me print it now to verify. So what you got, employee 6 is having more. Okay, employee 6 is having max age out of all the employees. So you got one employee details, right? So or you can directly use, instead of collect method, min max methods also, like what we discussed in previous cases as a terminal methods. So those are all given as a shortcut methods in the recent Java versions. But at one point of time, we used to use collect and followed by the collectors min by max by like that. So now let's move to the one more method as part of the collectors called as joining. So the name itself telling we are going to join some values. So for example, let's see, I want to get all department names with the delimiter means separator, delimiter 3 columns I have taken with the delimiter 3 columns. So what I have to do, see here. So that is what, if you are good with one, if you are practically good or you are able to understand the previous operations, it's all about almost common what we are doing in anywhere else. Okay, stream dot collect, and as part of the collect, what we are trying to do, collectors dot joining. So right, joining. So what you are trying to join here, the department names, right? So what you have to collect, joining department names you have to collect. So but that means before that what you have to do, you have to get the department names. So that's why I am writing mapping. So first I am mapping from the employee to, that means I can directly take, okay, like this method references also in this case, what it is, get departments, right? And from that you are collecting each and every department name and you have to join. You have to joining with char sequence of delimiter. If you have a prefix suffix also, okay, you can add some prefix word and suffix word, then also it will base for every value it will add a prefix, it will add a suffix, and internal it will add a delimiter also. If you are using joining, what will happen? So simply the department names will be joined without any delimiter, without any space, something like that. Okay, 1 2 3 something like that you will get. So if you have a delimiter, so then you have to provide the delimiter. Here it is. So what is the my delimiter? Here it is. It's all about 3 columns I have given, right? So let's say here, now I'm going to get all the department names with this delimiter or not. Okay, so what you are going to get, again a string value. You are getting a string value, string all departments. Let me print it now. See here, you got security department, finance department, and everything is separated by the delimiter called as 3 columns, right? So now this is what about the collectors class, and we do have a couple of other methods, but these are all popular methods, and those other methods also similar to these all methods only. So please refer the other methods, almost copy paste or similar to these methods implementation only. So this is all about the collectors class, and we are using as part of the collect method. So collect is a terminal operation. We will use collect method to accumulate stream values into respective required result type, like collection, summarizing the values, okay, grouping the values based on the properties. So all utility use cases being covered by the collectors class. So that developers can straightforwardly we can use these features. We don't need to write down again a manual logic to achieve all these functionalities. This is all about the Stream API operations. Before winding up the Stream API session, so here what you have to remember, here it is. First thing is what you have to practice. Here it is what is a stream object, how to create stream object, and then you should know what is intermediate operations and what is terminal operations, how we are joining intermediate operations and followed by terminal operation. Okay, in which order the operations are getting executed as part of the stream pipeline. So these are all things you have to remember. Along with that, you have to remember the collect method. In collect method is having a special utility class called as collectors class, and collectors is providing lot of utility methods to wind up the results from the stream instances. So see here, we made almost lot of operations with respect to list of employees. We implemented a lot of requirements, but when it comes to the source code, okay, precisely very less amount of code we written, like around 200 to 300 lines, right? But we implemented almost around 30 use cases. But if you want to achieve same use cases with respect to old approach of Java programming, like until Java 7, hopefully it will take another 400-500 lines of code also. Okay, so that means It is just like declarative programming, and it is encouraging us to make the declarative programming. Internally, it is encouraging or involving what kind of concepts, guys? 100% functional interfaces and lambda expressions and method references, as well as default methods, static methods inside the interfaces, and it is forcing us to utilize or use the optional class also. So that's all about the Stream API. Let's connect with next session. I'm going to make a next session interview questions as part of the Java 8 futures. I will make a interview questions series, which are, first thing is giving priority to the Java 8 futures, because this is the most important futures and being asked in interviews, and as well as we are using in daily basis in our day-to-day programming also. So thanks to everyone. So please let me know what are the sessions you are expecting, and I will try to make those sessions. So please share and subscribe so that I can reach out to more people and I can start making more sessions. Thanks to everyone.